Let's talk about the systemic effect of cytokines. So, as we saw in the previous video, cytokines are small molecules that can be released from cells and act locally in a tissue and on blood vessels that lead to that tissue. But cytokines, if they enter the bloodstream, can travel throughout the body and find distant targets. And that's what we refer to when we say systemic effects of cytokines. So here's an example of a macrophage with some toll-like receptors on its surface. And let's say the macrophage that's located in some tissue in the body binds pathogens via its toll-like receptors on the macrophage. So, as we know that the macrophages can release cytokines such as TNF-alpha, IL-1, and IL-6, and they have effects locally, but these cytokines can also enter the bloodstream and travel to distant targets. So let's talk about some of those targets. So, for example, the hypothalamus. The hypothalamus is the master control center in the brain, and it regulates temperature. And so fever is induced by the hypothalamus because of these cytokines, TNF-alpha, IL-1, and IL-6. So an infection in one part of the body can signal to the hypothalamus via these cytokines to increase the temperature of the body. Again, why would we want to increase temperature? White blood cells seem to work better at higher temperatures, and pathogens seem to reproduce more poorly at higher temperatures. These cytokines can also travel to fat tissue and muscle throughout the body to also generate heat. So the increase in body temperature is due to systemic effect of cytokines. These cytokines can also travel to the liver, and there are receptors for these cytokines in liver cells, and what the liver will do is the liver will produce about 30 different proteins in response to cytokines. 30 different proteins are turned on, or more. Their expression is increased. They might have low levels before, but they're going to have high levels now. So these are called the acute phase proteins. So there's an infection detected in one part of the body, cytokines will send for help to the liver via TNF-alpha, IL-1, and IL-6, and the liver will produce many different proteins that are going to help boost the immune response. We know that the liver produces complement proteins, and in fact, some of those complement proteins now increase in production, like C3, C4, and C9, and factor B. So you have an increase in protein production. The proteins were there before the infection. They increase even more after the infection. There are two proteins that we're going to spend a lot of time on in later videos called the CRP and MBL. So that's C-reactive protein and mannose-binding lectin. Those proteins are going to play very important roles in activating different pathways of complement. We'll get to those in other videos. So these are some systemic effects of TNF-alpha, IL-1, and IL-6. Now I want to talk a little bit about some bad things that can occur when there's systemic inflammation. So macrophages, where do you find them? They're resident in your tissues. So you're going to find them embedded, in the connective tissue in your skin. You also find macrophages in your spleen and in your liver. And so the spleen and the liver work very similar like lymph nodes. They will act as a filter for your blood. So you have a lot of blood going to your spleen and to your liver, and if pathogens are found in the bloodstream, and that would be known as sepsis, so pathogens or pathogen products in the bloodstream, you want something to be able to detect those and respond. And so your blood enters your liver and your spleen, and macrophages embedded in the spleen and the liver will sort through things found in the bloodstream. And if it engages via its toll-like receptors, such as TLR4, then it's going to release cytokines that are going to have a response. So the spleen and the liver play a big role in detecting pathogens that have somehow entered your bloodstream. Now, if that's the case, you're going to have massive release of TNF-alpha into your bloodstream, and it will travel all over your body. And we talked about some of the systemic effects. But if there is a high production of TNF-alpha and it goes all over the body, it's going to have some of those same effects on the blood vessels all over the body. So we talked about localized effect of TNF-alpha. these can be dangerous systemic effects as well. So locally, TNF-alpha produces increased vascular permeability and vasodilation. So that's good for a local effect where you want some swelling, some heat, some more blood. But imagine all over the body, blood vessels all over the body, increase vascular permeability and vasodilate. So you're sending all this blood to all sorts of places, and the blood is leaking, the fluid is leaking into your tissues. So what happens is massive swelling in organs around the body. And so you have dangerous edema. So your brain swelling, you might have swelling in your lungs, in your tongue, other places, and this edema actually will start to damage organ and tissues. The other thing that happens is all this fluid is leaving your blood, and your blood vessels can collapse because the blood pressure has dropped precipitously. When fluid leaves your blood, when blood vessels dilate, the pressure on the walls of the blood vessel will decrease. There's less blood in there and there's more room in there. So you have dangerously low blood pressure during sepsis, and that can lead to blood vessel collapse. Blood vessels collapse, and then there's no blood flowing to tissues, which means there's no oxygen and nutrients flowing to tissues. So organs and tissues will become damaged via swelling, and then they will become damaged because they don't have access to blood and oxygen and glucose. And what happens is something called septic shock, where organs and tissues start to shut down, and it leads to death very commonly. There are about 100,000 deaths in the U.S. every year due to septic shock. And one of the main causes of septic shock, pathogens entering the bloodstream, and those pathogens triggering the release of cytokines such as TNF-alpha, and they go into the bloodstream and cause massive systemic inflammation. So blood vessels dilate all around the body, vascular permeability increases all throughout the body, and fluid leaking into tissues causes tissue damage, blood vessels collapse, and blood flow stops to essential organs and tissues, then death occurs. So that's this video covers systemic effects of cytokines as well as dangerous effects of cytokines, such as in septic shock.